we're going to look at the definition of a derivative. The definition of a derivative is the derivative of f at x is given by f prime, this is a derivative, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x, provided the limit exists. Now, you should recognize this because this part right here that I'm going to circle in red, this part right here is the slope of the tangent. So you can think of the derivative as the limit as, get my pen here, the limit as delta x approaches 0 of the slope of the secant. Now, there are some steps I want you to follow when using the definition of a derivative to find the derivative. First, I want you to write down the definition. Yes, this wordy thing right here every time. Second, I want you to substitute in. Now, remember, when you're looking at f of x plus delta x, you're going to replace in your function, everywhere you have an x, you're going to put in x plus delta x. So if my function is x squared, when I plug it in, or when I substitute in, this becomes x plus delta x squared. If my function of x is 2x cubed minus 1, then f of x plus delta x is going to be 2. I'm going to put in x plus delta x cubed minus 1. So do that substitution. Do it for f of x plus delta x minus f of x divided by x. Simplify your numerator, factor if possible, and then take the limit. All right, let's take the derivative of this function right here. Step 1, write down the definition. So it is the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Step 2, substitute in. This is the limit as delta x approaches 0 of, now f of x plus delta x, this is going to be a bit of a mess. It is x plus delta x quantity cubed minus 2 times x plus delta x. Now for sanity's sake, I'm going to put brackets here, minus f of x. So this is the second part, x cubed plus 2x all over delta x. So this is step 2. That was step 1. Now step 3 is to simplify, which means this is algebra. I just need to multiply this out. This is a limit as delta x approaches 0. Now x cubed, you can do use Pascal's triangle or whatever you know. So this is x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus, now I'm going to multiply this out. All right, that should be a plus, shouldn't it? Sorry about that. That should be a plus. Plus 2x plus 2 delta x minus x cubed minus 2x all over delta x. Now I'm going to continue simplifying here. Does anything go away? X cubed goes away. Minus 2x should go away. And I'm left with 1 delta x. There's at least 1 delta x in every term. So now I'm going to move on to step 4. Let's make step 4 in black. Okay, so this is the limit as delta x approaches 0. Now I'm going to factor that delta x out. 3x squared plus 3x delta x. Did I do that correctly? Plus delta x squared plus 2 all over delta x. So I factored, and you have to do a little bit more simplifying here. The last thing I'm going to do is come up and actually take the limit. So when I do this, there is no delta x in this term. There's 1 here and there's 1 here. So let me rewrite this so you can see what we're doing. I'm left with 3x squared plus 3x delta x plus delta x squared plus 2. Now when I take this limit, that goes to 0 and that goes to 0. So I'm left with an answer of 3x squared plus 2. And each of these steps is important, and you need to show them on your test papers.